Hear me and see my screen.
Yeah, sir.
Uh, Thank you for the opportunity. It's my pleasure to be here today, and thank you for the kind words. It really takes me back to my days in engineering, and also a very good afternoon to professors as well. Today, I just wanted to share Industry 4.0 as a topic. And one of the reasons I'm sharing this topic is I was told to talk about uh, a topic which introduces technologies. And I thought that this is an interesting topic because it brings together a plethora of technologies. Secondly, putting myself in your shoes when I was an engineering student myself, there are courses, um, programming, networking, many courses that we study during engineering. We also do our final year projects. But really, when once you have an industry exposure, it sort of makes you realize that technology is the beginning. At the end of the day, when we enter industry or when we apply technology, it is to solve a problem, a need. And during this, one realizes that we need to visit the industry, look at the problems that the industry is facing, and then it doesn't just remain about the technology. You look at the actual circumstances in the field, you look at the people involved, the processes. And as part of my work, I've had the chance to work in telecom industry. So once you go out to any industry, or for that matter manufacturing, or a bit in healthcare, banking, you go there with a certain knowledge of your industry, but it's important your skills, computer skills. But it's important to understand and put yourself in the context of that particular industry, which means you need to pick up some domain skills, understand how the industry works. And today's example is one such where I'm going to give you an overview of things. Each industry is evolving very fast. COVID has really taught us that whatever we may have learned, or the systems that we had put in place, face unseen, unforeseen challenges. And how do we react, right? And that's why I put all the three aspects: people, processes, and technologies. Because whether we are reacting to an unforeseen situation like COVID, or you are reacting to change in competition, globalization, or competing with other players, all these aspects come together. So, in the next half an hour, 40 minutes or so, I'm going to try and cover some things that I was exposed to. Industry is changing fast. Maybe you have seen many things yourselves. And these days, with the access to internet and with the access to information, all of you can see, read things, and everything is evolving very fast, right? For instance, if you are reading the newspapers today, there's a lot of information that is being talked about in the field of artificial intelligence, generative AI, for example. So technologies change very fast. Once again, the thing is, what is the need? How are we applying technologies to it? And as part of it, are you understanding the domain? So let's get into this particular domain, which is around manufacturing. We've known of industry and manufacturing for a long time. So this chart briefly tells you that from the 1700s to what we see today, manufacturing itself has evolved from a very mechanized industry to it going towards mass production. Then we saw the advent of computers coming in, and today we are talking about cyber physical systems, IoT networks. So why only the manufacturing, right? If you look around your house, your college, or your um, surroundings, you're seeing that all devices today increasingly are becoming not standalone but connected devices. So whether it is an AC that you have, or a water cooler, or for that matter any systems that you use are connected to the internet. So it's all connected, it's all networked. And there is a certain level of efficiency as a result of this, digital connectedness. Now, let's look at the manufacturing value chain itself. And you've seen cars, for example, or the automotive industry as a whole. There is always the product aspect of it. So there's, the product design, there's, material involved in it, there's requirements management around it. Then at a high level, you move towards what is required to manufacture it. So there's material, but then it needs to be procured. There's the inbound logistics piece of it, storage of it, and then the actual manufacturing, followed by the outbound logistics, warehousing, and then distribution and complete marketing, how it is advertised to the end customers, how it is positioned, sold, and so on. So this briefly gives you manufacturing. Now, as computer engineers or as engineers, software engineers, or people from other engineering streams also, this sort of tells you that how software starts playing a role. Because now if you look at the application lifecycle management, you're talking about gathering requirements, you're talking about change management, quality testing. Then when it comes to the product design, the physical aspects of it, the material that goes into it, there are all these steps around material, product data, documentation, design. ERP and supply chain management talks about, let's say the inventory, the forecasting, vendor management, raw material, how the whole production is being planned, and then it's being executed with manufacturing execution systems. So the actual batches, actual, the assembly lines, the quality that is produced, what is happening around the output, are there any problems, anomaly detection, root cause analysis, and all of this at the end of the day, like we discussed, is connected, right? So we are talking about increasingly machines being connected, we getting, whether it is utilization on the shop floor or whether it is dispatch or whether it is incoming materials, the planning of it, this whole thing is a connected chain with software, right? Now let's look a little bit about the adoption piece of it. So when we talk about digital, what are the challenges that manufacturing industry, in many cases you can also compare with other industries. So there's always, when there's a change, there is a there are choices, and especially when it comes to technology, it could be confusing choices. Then once again, every day you cannot renew everything, right? There are legacy systems in place. You don't throw away everything even when you, let's say, I mean, just for layman's terms, renovate your house, right? There are existing things that you would use, and then there are some things you would renew. Because we don't live in a ideal world, there are always constraints, whether it is that of budget, whether it is that of, having a complete, vision, time, expertise. So all the blocks that you see below also involve the other elements other than technology, which is people and processes piece of it. How clearly is the management thinking about this transformation? Once again, COVID example. How do you react to a situation like that? How can you handle change? What is the dependency with your stakeholders? Let's say if you want to progress and adopt new technology for the future, are your today's workers ready for that change, right? If people are used to using certain systems, you're going to put them on new systems. There's going to be training, there's going to be change management that is involved. So these are some real life aspects which also come into play when moving towards digitization or technology. This is a busy chart, but I'm going to sort of simplify it for you. Now, when we talk about this whole industrial or manufacturing piece, right, think of it as three pieces. We are talking about the product itself. This is the first pillar where you think about the design and engineering of the product, what happens around its prototyping, its design, what materials go into making of that product, quality, all of that, and systems that help manage these, right? The application lifecycle management, including requirements, product lifecycle management, which is, let's say, the design of the physical product. How do you visualize it? CAD, CAM. You've heard of these terms. You've heard of, um, then actually prototyping it. So today, possibly you have even heard of 3D printing, which is more to do with or additive manufacturing, as they call it. Um, but the actual manufacturing and operations then needs to look at the larger shop floor assembly line, the supply chain involved, the inventory, production, scheduling, all of that with quality, with traceability. And then the which is the second pillar, and the third is the customer pillar, your market. What are the orders coming in? How do you position yourselves? Are you able to cater to that order in time? How is your distribution and logistics, customer and field services, your salespeople, all of that. So all of this is managed by software today. It is increasingly connected systems. And then you think of the scale, right? This is not about one factory. It is not about one product. You're talking about multiple factories. You're talking about multiple products being produced. Now, how do you learn from one setup what is happening there? You scale it, you look at similar productions in the other setup. Is there a variation in quality? Is there a difference, or is it exactly the same? If there is a variance, why is there variance? If there is a problem, how do you go to the root cause of it? These are all the challenges that the actual end manufacturers face, and we as software people are involved in all of these cycle. So when customers look for it, they are looking at managing revenue. They are looking at their cost control. They are introducing new products, differentiation aspect. There is customer success, brand building. All of these outcomes are essential for them. To achieve all of this, we use technologies, right? Data is of essence. Data is the new oil today. I'm going to talk a lot about this aspect of it in the presentation. You hear about artificial intelligence and increasingly machines becoming intelligent, usage of cloud computing, internet of things we touched upon, mobility, wherever you go today, whether it's getting information on the device, at move, all the time, helps in decision making. So at the end of the day, in many ways, it's all about data being present at the right time to make the decisions, right? Whether you receive information or you process it and you give it, feed it back into the systems. Increasingly, human control is being reduced, and we are talking about closed loop automation. What does this mean? So something happens somewhere in this chain, you get information about it, you manually read it, you react to it. Increasingly, the pattern is known. Just like the human would react to a pattern, the machine is taught to react to this pattern, and the action instead of taken by human being is taken by the machine, making it a self-healing, self-operating kind of a system, right? Then AR, VR aspects of it, right? A lot of knowledge today is acquired by human beings. We know of people working on the shop floor for 20 years. So when such an experienced technician goes to a machine, he or she knows absolutely how to work with it. They can hear the noise of the machine and can say if something is wrong with it, right? Increasingly, machines are going to learn this and are learning and already being deployed. But for example, if there is a new trainee, can I, how do I train the trainee? Traditionally there were manuals, there were sheets which people would refer to. But today, you're in a position, first to use a simple device. You can point to the machine with augmented reality. The machine is able to, the system is able to see that there is a pattern. The pattern matching happens. The machine is recognized, and boom, you see a user manual opening up on your mobile device. Now, why only a user manual? There's a video. How can you operate the machine? These are the typical problems with it. The machine will tell you more about diagnostics, and you enter into the world of smart diagnostics, right? You go a step further. You have immersive reality. You wear a glass, and that glass renders the image of the device. You can work with gestures and see how the machine can be dismantled, and what could be the possible problem. Yeah. For those who have not seen this before, you possibly have operated a printer, right? The printer tells you where is the paper stuck. That's just a smart diagnostic piece there. This has gone way further now. You can actually see the machine in 3D and you can do operations. And if you are not able to do this on the ground as technician, you have connectivity right there. Press a touch screen, you connect to a remote technician who is able to see what is happening on the shop floor and then able to guide you remotely. Not only guide you remotely, on that touch screen, you will also see information annotation coming in to help you solve the problem. That is the level of change that software today has brought, digitization today has brought, and connected technologies and machines are able to help us solve problems in remote locations or on factory shop floor, right? So data edge computing is another aspect which I'll touch upon. But some fact checks today, right? So let's say if an industry is operating for decades, it doesn't happen that the systems are all very well aligned, right? There may be a old, project product planning system. There may be, some manual Excel sheets being used. There may be an old ERP, and there may be some systems which are not talking to each other. So many times I've experienced that visiting a, a manufacturing setup, the supervisor doesn't get the right reports because the reports have to come from two, three different systems, or to generate a bar, like a end of the week report for the management, they have to sift through data which is there. These are the realities of life. The human factor today is helping them do this manually and deliver it. But as industries are transforming, this is not sufficient because speed is of essence, productivity, efficiency is of essence. All these supporting departments need the right information in place. So this needs to be well aligned. So data is of essence, and we are talking about data stored in disparate systems, and how can we have these systems, getting them connected and getting the required information for various functions, whether it's sales and marketing, whether it is engineering or quality, to produce the right output or to work at right efficiency. Right? This requires a certain level of connectedness and bringing systems together digitally. Right? Now, this is actually the challenge that the industry is facing. Chaotic systems, fragmenting systems, data not being there really results in the bottlenecks, right? And it is your technology knowledge, your understanding of the domain, and applying it helps you get there. Now, let's do a quick check on, you know, data in manufacturing. You would see that at the end of the day, by achieving this connectivity, what we are looking for is the right information, the right data to handle various aspects, whether it is market forecast, design, production. Right? Data is a key piece here, right? And you see some of the top cases, whether it's quality management, process control, operations management. All of these aspects need the data to be there, right? Now, let's look at the people aspect of it, right? Who are the decision makers typically? Yeah, the operations manager on the floor, right? And you can think of any other business as well. People in key positions, whether it is supervisor on the floor or the senior management person, or an operator on the field, they need the right information, whether it's about looking at the next case on the field and having information for that, or what is happening on the shop floor in the production, or a CXO who's looking at larger decision making. All of them need to have the right information, which means having dashboards. And when I talk about dashboards, I'm just giving you these key parameters. We don't need to get into each of the parameters. But if you think of overall profit, or whether it is operation of the machines, operation equipment effectiveness, getting things right, workplace injuries, all of this require right data coming from different places. And I showed you the spaghetti, and I showed you various systems involved, right? The challenge today is to get this in place is a lot of effort for industries. Right now, to calculate these parameters, I'm just giving you another sample of from where does this data come, right? It could actually be operator logs. It could be various, RFIDs which are installed. It could be in the warehouses, tracing how the machines are moving, or how uh, you know it, stocks are stored in the warehouse, how the operator is retrieving them, demand forecasting, supplier provided data. All of these systems processes are emitting data, right? And then we spoke about the people and process aspect of it. I'm just highlighting here that functional leaders need certain information, supply chain leaders need certain type of information about, let's say, orders, and then the CXO that I said, they also need certain type of information. It's not to get into each parameter and each information, but just driving the message. Now, when, let's say, you create a dashboard, right? We today, software as having these elements. There may be a drag and drop, but to that, you will have to have all these industrial data sources, connected information coming from various, understanding the industrial technology stack. I showed you the various software and systems that come into play. Then thinking about the ease of use and the mobility aspect of it, you use appropriate charting libraries, you bring out information from tens of these sources, data sources, and this is what then helps you drive the correct reports for making that decision. So this is just an example of how a small in piece of information that you see is actually coming from all these data sources, all these systems talking to each other, connectedness, and so on. What does this help you achieve when a situation like COVID strikes, or if there is a cyber attack, or any change in demand, let's say orders are cancelled? There is this whole connected chain today that helps you adapt to it, right? You can tell your suppliers what has gone wrong, you can talk to your vendors. Other way around, I'll tell you, we'll get into some examples and case studies where if something fails on the field, then you know exactly the source of that failure up to that batch. Just to tell you a little bit further, because you're students, um, the data is available in various time frames and formats, right? When you are closer to the shop floor, or to the production, you are getting data in seconds or milliseconds. As you go more towards the higher levels of abstraction towards production and planning, that data, the planning actually happens much earlier, or that information is planned much earlier. So you have this connected systems, you have various types of data, and then you have your planning and decision making systems. I think by now you would have fairly got an idea of the overall topic. Now, what are the aspects that people want to change? The top five, I'm just pointing out. It is focus on quality, better forecasting, operational excellence, process improvement, and customer service. These more or less go along, the production aspects, the customer aspects, and so on. Now we'll get into one use case which will tell you, and who are the people, right? I previously touched upon decision makers, but look at the number of people, number of roles who need this information, the interconnectedness of their roles, activities, production, and actual systems in place. Second piece, as I said, it's not one factory, it's your operations around the country, increasingly with multinational companies around the globe, that this information needs to be available to the staff. And very clearly, now let's take an example, right? Many of us have heard in the news that, I'm just saying, Toyota, for example, or Nissan for that matter, this example talks about that, has recalled certain cars, right, from the field. Now, how big is this ecosystem? If you think about car returns from the field, and I've got a little bit of exposure to how rigorous the testing is, both from a automotive world, and I've worked in the telecom industry, so the telecom world, and you are from the software world. You know that we say, from a economics perspective, The earlier that you discover a problem, the better. So if you figure out a problem while coding, it's much better than when you code it and put it out on the field. Now scale this up to automotive industry, which increasingly has a lot of software. If you detect a problem on the field, like the car returns, how expensive an affair that is. You're talking about this whole big vehicle being returned, right? And then you start doing your root cause analysis. Now look at all the pieces, right? So what are the, how do you start gathering this information? Just think of it in the sheer terms of data, and this chart will give you an idea. Voice of the customer, right? What is the customer? So increasingly now with social web call centers, people are going to start putting, be it Twitter, on social media, wherever, that there has been some problem. So you start getting information from field as voice of the customer, which is the first box here. You say likes, dislikes, there is certain sentiment. People are calling up call centers, people are returning and talking to their service center and warranty. So this is one piece of information, right? And then you start relating to other factors. For instance, the vehicle itself. Increasingly with connected vehicle, there's going to be some data gathering that's going to happen. The vehicle is going to relay some information. So there is the voice of the vehicle as well. You can get telemetry data from what is happening, etc. Then comes, you start sort of tracing what happened, and then you start moving towards why did it happen, right? You say start figuring out that, is it a issue that is in certain parts, is it only in certain parts of the world, let's say only in regions of India, or is it also happening in South America? And then you go back to the production field, and so you hear it from the field, certain installed base, and then you go to, is it something to do with, certain factories? That's the voice of the factory. Then you see, is it only found at certain suppliers, and so on, right? So you sort of go from a higher level and keep moving towards the source of information that will let you first contain the problem, segregate it, and address it. So there's going to be data coming in from all these parts. Now, think of, so this is an example where certain quality analytics for Nissan were done. Initially, they lacked the infrastructure for this kind of a 360-degree analysis. As a solution, they actually built a data lake, which helped them get data from various aspects. Now, let's get a little deeper. We spoke about data. Earlier I had shown to you systems, right? So there will be certain transaction systems, whether it is your ERP, manufacturing execution systems, quality maintenance, etc. You'll be getting some information from there. The other, like I pointed out, you will get information from your connected manufacturing systems on the factory floor. So there would be historians, you stored data, ingested and stored process. You would start analyzing all of this information from these various sources. Then you start figuring out, you see that there is a pattern to it, and then you do the reaction to it, that you uh, then fix the problem. Now, can you do the same thing with plant maintenance? Yes, you can. So basically, it's all about getting the data, identifying, storing, processing, analyzing, increasingly learning from that, and reacting to a situation. So that's why, I spoke about all of this. Now, other way to look at it is, when people are working on the field, these are sort of the questions you ask. Are, from a persona perspective, are the functional leaders getting the right data sources? Do they have the required data for compliance and traceability? How do they manage changes in this product life cycle, right? So these are, when we as solution providers look at it, these are some of the aspects that we go and talk about and check, and then design our systems, which include connecting existing systems, getting um, information from systems of records, having layers which are built to tie them to information which are more real time, identifying patterns from it, being able to figure out if there is something that can be done preventive in terms of maintenance, or then if something has gone down, then you react to the situation based on the data that is being collected. right? So I've spoken sort of many things here. I'm going to bring it together with some examples of real life things where we face situations, and these are some examples uh, where we have faced um, various types of manufacturing situations, whether it's in some situation an aluminum foil manufacturer who were facing actually coil breaks, and it was happening only in a certain setup. Some information was gathered from the existing setup. A particular setup where this was happening was isolated, and then some data was retrieved, dependency studied, and this resulted in overall understanding. It was certain setup and certain configuration of elements and what went into the aluminum foil manufacturing, some chemical composition which was resulting in this. Similarly, we've heard of PPE kits more during COVID, but think of personal protective equipment like safety glasses being worn. We, there have been systems designed where if you walk into a door, the camera is able to detect whether you've worn safety glasses or not. Right. Similarly, having the right dashboards. I spoke about some dashboards which help get information from these connected machine, and monitoring effectively then reduces the unplanned downtime. Of course, as this information comes in, there is more scope and possibility of doing and preventing unplanned downtime. I'll get, I think there are still 15-20 minutes, so another 5 minutes. I'll quickly get into some more details of these examples. Um, I have some case studies here. So this is an example of personal protective equipment being detected through a camera-based system to see whether a person has worn a camera or not, right? So this essentially leads to improvement in safety aspects of it, right? So what happens here, right? The machine or the cameras have the image, the Edge ML detects these, and there are certain events and responses which can be shown on the dashboard. In the background, basically, there's a model that is being trained. It's been deployed closer to the data source, and then there is a check that happens with the actual location. I'm going to flip through these. This is just to give you a sense of some actual real life examples, right? Once again, I told you about monitoring of factory shop floor systems. This is about more about having dashboard to monitor KPIs. So when you get into bearings manufacturing, it's there are various functions: grinding, dressing, clamping. Once again, examples of machine which need to be connected, certain information got from these various systems, having an effective dashboard to monitor it, alerts which are sent to the supervisor wherever the person is, helps them get instant information. And many of these can be made even self reactive, like if there is certain threshold that is passed, stop the system, and so on. I think by now you're familiar with these things. Maybe I'll take a pause here. I'll quickly check on the questions which are coming in. Just a last example on energy consumption monitoring. You would have heard of meters, smart meters being installed, and when we say meters being smart, they're essentially deployed and they're connected. So break the product down into multiple assembly lines. At each stage, when a smart meter is added, you can actually get information about the energy consumption and then control various parts of these processes, either change the assembly time. Abroad, there is also possibility of choosing your supplier. You can change the load of your production to off peak or at the right time of the day to balance energy consumption and so on. All these examples, I'm just trying to basically tell that connected machines help to get the right data. Data is key in decision making, and essentially we are enabling decision makers with the right data, right time to take decisions. Next stage is where these decisions are based on patterns. So increasingly machines are becoming self-sufficient, where they recognize patterns and then take the decisions to automate this and make it a closed loop. I think with that, I'll take a pause. Uh, we'll stop here, and then maybe if there are some questions, I'll just take questions.
Yes, sir. Thank you, sir. I request all the participants kindly drop your questions in the chat window.
Sorry, let me check. I may have. Yeah, while you put up questions, I'm just remembering some other examples. If you think of warehousing or storage systems, right, you will be amazed that I've been in situations where you've seen these, on Indian roads, we've seen tempos, right? I've been to a tempo factory where they make these tempos and they put it in their large yards. And as they are produced and put in the yards, the manufacturer told us that some of these tempos are actually lost in the yards. So, what can we do to implement a traceability system for them? Uh, very, so you can think what can technology do in such situations. I'm just giving you examples. In another case, there are these steel rolls which you would have seen on roads when you're traveling. These rolls are put in various warehouses and they need to be tagged. Uh, right. Similarly with tires. In tires case, there is even a perishability aspect involved, right? So if first in first out, so if they produce first, they need to be put out first. So the entire warehousing mechanism needs to be designed in a way that these are put in yards, and then when the carrier comes to take it away, then it needs to be sent out in those orders. So software systems also help with this, whether it's Bluetooth low energy tags. In another situation, uh, there have been usage of QR codes, which have been used to do assembly line traceability. Example, a large truck being manufactured, right? On the assembly line, previously they had pen and paper based system. The kitting would happen, axle kitting would happen with people getting these parts, putting them in a tub, they would assemble, pass it on to the next station. There, the fitting person would do the next fitting, pass it on to the next system. But when we went in, we realized that there is actually a way to tag these systems with QR codes or barcoding for that matter. And then from each kitting station, you pass the piece to the next station. This assembly actually gives you information from the PLCs, programmable logic controllers. Now, at each station, basically, then you start getting digital information which was earlier stored in paper. We simply introduced a workflow mechanism of storing this information, which resulted in a digital traceability of this supply of this assembly line. Now, when this axle went out and was part of a larger truck assembly, and the trucks, if they failed on the field, it was possible to trace this whole thing back to a particular factory, particular assembly line, particular. This is a simple example of digitizing and getting digital information to be able to go and trace back to the original system. Some more examples. You heard of steel production, right? I've had the opportunity to visit and stay in a steel plant, and it's very interesting that the raw material that comes in from the sea, and there are sea routes which take this material into the actual factory, which is more inland. And there are barges that operate on this sea route to the inner, let's say, channel, which takes barges. So these barges are like large container type ships. Imagine a container moving on water. So these barges are like containers. So ships which come on the sea unload this material on these containers, and then these containers take them through this water channel route to the factory and unload and come back. So their production depends on the efficiency of unloading, traversing, and again sort of loading it onto the local factory chain that takes this raw material into the factory. So we were asked to do some optimization around these barges. Another example of when you go out in the field, you're told about some real world problems, and then you see how software and traceability could help improve things. I'm not sure if I'm missing something, but I don't see any questions on the chat.
There is one question in
Yes,
chat
I'm.
window.
What are the upcoming projects we would expect in the field of AI in near future, and how about scope of patent in data analytics and data mining? I can answer a part of it, especially the uh, what in the field of AI, right? There's possibly every field where AI is being deployed today. When it especially comes to the latest trend, you are seeing a lot that is happening in the field of generative AI, and um, in terms of projects, right, you think of various aspects. In fact, in the production as manufacturing examples also, you saw these three pillars. There's the product, production, and customer experience. Now take an example of customer experience, for example, today. um, you know Conversing with a human or conversing with a bot, how well can you talk to the customer and resolve the queries upfront is really essence of retaining the customer. And this means understanding a lot of information which is about the product, production, and giving out that information in the context of the customer, so that whether the customer is calling for the first time or second time, third time, you are able to answer the query immediately to the satisfaction by accessing all of this information. This is a simple example of improving customer experience. So AI is going to be there in that, answering your customer queries or digital assistants as we know them today. Increasingly, AI is being deployed in vertical specific solutions. Today, we spoke about manufacturing. So, take the example of predictive maintenance. Let me talk about machine failure, for example. There are only, if you talk about a certain machine, right, there is only a certain number of ways in which it has failed. As we were working in the field, we were told that a company has actually modeled that there are 800 ways in which the machine can fail. Now, with this kind of understanding, you basically have a pattern that you go back to. And when it comes to operating that machine, so let's say you purchased a machine from a supplier, whether it is Siemens or Schneider's or whichever machines you have on the field. Now, if it is known that this machine fails only in certain number of ways, you're observing parameters from these machines, right? These parameters in turn help you say what is the health of that machine. As the parameters keep emitting value, it's possible to figure out that whether this machine is going to fail, and that extrapolation happens, and you're able to do preventive maintenance. Increasingly, we are talking about this happening: preventive maintenance, predictive aspects of it, and prescriptive, right? So the prescriptive part is where you are able to tell customers in advance that you need to do ABC because we are seeing this trend happening. So in the scope for AI projects is immense, and you're possibly not only asking about manufacturing. So let's say if you're in healthcare, it is all about personalized treatment today, right? If you go to the doctor, you get a certain level of treatment because of symptoms. But today it's possible to go to person of one. So, understanding your genetic makeup, understanding your genomic data, it is possible to personalize medicine to the extent of one, which means artificial intelligence is playing a role here to be able to, help you get to that personalization of one. When you move towards other industries, clinical trials, you're talking about pharma industry, you're talking about patient cohort matching. A lot of artificial intelligence today is used to do the right level of matching, bringing the right people to the right place to get right treatment, which sort of helps improve outcome. So there is, you know, endless scope for artificial intelligence. Now, this latter part about patent in data analytics and data mining is something that I will have to look into. If you have more details or specific, you can write to me at mandar_gyan@persistent.com. I'll find out more about your query and get back on this.
Thank you, sir.
Thank you. I think there are no more questions. Uh, you have a few minutes back to your time, and I really enjoyed your talk. We can still continue to be connected. My email ID is mandar_gyan@persistent.com. You can write to me or you can write to your coordinator, and I'm happy to answer any queries. Would have been great to meet you in person. It's a different experience. Um, Thank you for the opportunity to Bytes organizers. Thank you. Good day.
Uh, Thank you, sir.
Thank you. Bye bye.
I uh, I thank Mandara Gyan sir for such an informative session on Industry 4.0. Now I request Mandara sir to accept virtual memento as a token of love and respect.
Thank you. It's a pleasure. Thank you so much.
Uh, Dear participants, I have dropped the Google form in chat window. Kindly fill the Google form. Now, I thank all the participants for joining Bytes Expert series. Thank you one and all. Before winding the session, kindly fill the Google form. Thank you, sir.
Thank you so much.
Thank you.